All right, let's dive into a really core challenge in modern software. So, you've built your system out of all these little independent services, which is awesome. But how do you stop them from turning into total chaos when they actually need to talk to each other?
I mean, this is the fundamental question, right? Breaking your big app into microservices is one thing, but now the real fun begins. How do you actually get them to communicate with each other in a way that's efficient and doesn't break all the time?
The best way to think about it is like managing a team of experts. If every single person is yelling across the room at everyone else all day long, you're not going to get much done. It's just chaos. To be productive, you need clear rules and methods for how they communicate.
So let's look at our first communication style. This is the most direct one you can imagine. It's basically the equivalent of picking up the phone and calling a coworker because you need an answer from them right now.
This is what we call synchronous communication. Service A sends a request to Service B, and then it just waits. It's totally blocked. It can't do anything else until Service B answers, does whatever it needs to do, and sends a response back. Now, it's simple and direct for sure, but it creates this really tight dependency. If Service B is slow or down, well, Service A is just stuck.
So when we talk about these phone calls, there are two main ways to do it. On the one hand, you've got the classic REST API. This uses HTTP, the language of the web. It's everywhere, it's pretty straightforward, and it's great for simple, direct requests. But then you've got gRPC. Think of this as a super-fast private intercom line that only works between your internal services. It's way more efficient for when you have a ton of internal chatter that needs to be lightning fast.
But let's be honest, not every single task needs an immediate phone call, right? Sometimes waiting around for an answer just slows the whole company down. And this brings us to a completely different way of thinking, one that builds a much more flexible, much more resilient system.
And this is the asynchronous model. So forget the phone call. Think of this more like sending an email or leaving a memo in a colleague's mailbox. Service A just sends its message out and immediately gets back to work. It doesn't wait for a reply. It just trusts that Service B will get around to it when it has a chance.
And here's how that flow actually works. Service A doesn't talk to Service B at all. Instead, it just announces an event, something like, hey, a new order was placed, into a central message queue. This queue, using something like Kafka or RabbitMQ, is like the central mailroom. Then, whenever Service B is ready, it just checks its mail, picks up that event, and processes it. The key here is that Service A and Service B are completely decoupled from each other.
So what's the big win here? Well, it's freedom. It's independence. Because the services aren't waiting on each other, you can scale them up or down independently. If your order processing service gets swamped, you just add more workers to clear out that mailroom queue. It doesn't slow down the service that's taking the initial orders at all. This is really the heart of how huge event-driven systems work today.
Okay, so we've got phone calls and we've got mailrooms. But to make any big organization run smoothly, you need more than just that. You need a receptionist, you need an address book, you need some safety procedures. So let's get into the essential playbook that makes all this communication actually work safely and efficiently.
First up is the API gateway. Just think of this as your company's main reception desk. You don't want clients from the outside world calling every employee's desk directly, right? No, you have them come through the front door. The gateway handles that. It routes all incoming requests to the right internal service, it takes care of security, and it basically hides all the internal complexity from the outside world.
Next up, service discovery. In a dynamic, modern system, services might move around. Their phone number, their network address can change. Service discovery acts like a constantly updated company phone book or an internal GPS. When Service A needs to talk to Service B, it doesn't need to know its exact address. It just asks the directory, hey, where's Service B right now? And gets the latest location.
Now this one is a total lifesaver. It's a pattern called a circuit breaker. Imagine one of your services starts to fail. If all the other services just keep calling it over and over again, they'll all get stuck waiting, and pretty soon your entire system can grind to a halt. A circuit breaker detects that failure and trips, automatically stopping any more calls to that broken service for a little while. It's a crucial safety net that stops a small problem from causing a total meltdown.
And finally, we have this fancy-sounding word, idempotency. It sounds complicated, but the idea is actually super simple. Doing something more than once has the exact same result as doing it just once. Think about it. What if a network glitch makes you send a place order request twice? Well, an idempotent API is smart enough to see the duplicate and only process the order one time. It's what prevents you from accidentally charging a customer twice. Super important.
Okay, so we've covered a lot of ground here. We've got different communication styles, different support patterns. So the big question, the one that really matters, is how do you pick the right tool for the job? How do you decide when to make that phone call versus when to just send a memo?
Well, honestly, it really just boils down to this. The choice is driven by what you need in that moment. If you have a user sitting there, staring at a screen, waiting for something to happen, you need an immediate response. That's a phone call. That's synchronous. But if you're dealing with background tasks, or if you're building a massive system that has to handle huge, spiky workloads, then you absolutely need the scale and the resilience that you only get from asynchronous events. And that really brings us to the core philosophy here, a really powerful piece of advice for anyone building these kinds of systems. Constant back-and-forth chatting creates fragile systems. The most efficient, robust systems are built on a different idea. They notify each other of important events, and then they get back to their own work. It's a fundamental shift from having conversations to making announcements.
And that's really the question I want to leave you with. Take a hard look at the systems that you're building or working on every day. Are they tangled up in a fragile web of tightly coupled phone calls, or are they built like a resilient, scalable team that communicates through efficient, fire-and-forget notifications? The answer to that question can make all the difference in the world.